solve 6b to the power of minus 2 minus 5b to the power of minus 1 plus 1 is equal to 0. Looks like we can solve by substitution again here, because if I look at these two terms, if I square this term here, I get this. So that would be a good candidate to solve by substitution. So I'm going to let b to the power of minus 1 equal to some variable, anything I'm going to call it. Let's call it x this time, x. So if I square both sides, if I square left-hand side and square right-hand side, looks like b to the power of minus 2 is equal to x squared. So if I substitute here, I get 6. Instead of b to the power of minus 2, I can call it x squared. And then instead of b to the power of minus 1, I can call it x plus 1 equal to 0. So now I can solve this by factoring or a formula. See if it's factorable. For those of you watching this with me live, is this factorable? 6x to the power of 2. How would I factor that? What would be the possibilities here? 1 and 6, 2 and 3, maybe 3 and 2? Let's try 3 and 2. 3x, 2x. If you look at the constant 1, looks like the possibility is only 1 and 1. So let's put 1 and 1 here, see if that works. Here we get 2x. Here we get 3x. Sure enough, I can make negative 5 x out of these two. So if I have both of these negative, I get negative 5. If I place negative here, sure enough, I would get negative 1 times negative 1 is equal to plus 1. So this is factorable. Like I said, if it's not factorable, we can always use quadratic formula. So this would be 3x minus 1 is equal to 0. So if I add 1 to both sides of the equation, I would get 3x is equal to 1. So it looks like x is equal to 1/3. Or I get 2x minus 1 equal to 0. If I add 1 to both sides of the equation, I would get 2x is equal to 1. So x is equal to 1/2. Again, we're not solving for x, we're solving for b. So we have to go back to our original assumptions. We assume that x is equal to b to the power of minus 1. So we can start with that. We said b to the power of minus 1 is equal to x. So we found two values here for x. We found x is equal to 1/3. We also found x is equal to 1/2. So if I substitute this here, b to the power of minus 1 must be equal to 1/3, or b to the power of minus 1 must be equal to 1/2. Can somebody tell me how do you solve for b now in this case? How do you eliminate this minus 1? Reciprocal. How about if I raise both sides of the equation into the power of minus 1? I can do that, right? If I raise both of the equations to the power of minus 1, I eliminate that minus 1. Minus 1. I can do the same thing here while I'm doing this. So if I raise both sides of the equation to the power of minus 1, this could be my result. I can see what b is. So it looks like b is equal to 1/3 to the power of minus 1, which is equal to what? Remember we had the property a over b to the power of minus n. What is that equal to? How do you make the exponents positive? Can we remember that? A over b becomes what? B over A, very good. Same thing here. So this would be 3 over 1 to the power of 1. So just 3, right? Or, so in this case, this would be 2 over 1 to the power of 1. So B is equal to 2, B is equal to 3. So these are our solutions. Solving by substitution method. Again, we can use this method here every time we can see these two terms are square of one another. If I take this term here and square it, if I get this one, then I can use this method.